All right, guys, we are back continuing our right triangles unit. We've worked on Pythagorean theorem and its converse. We've worked with special right triangles, and now we start to work on something called trigonometry. Now, our focus right now is going to be trigonometry in right triangles. Um, and there's a couple things that go into it. Not only do we have to know the parts of the triangle, we have to know the ratios or the formulas that go with trigonometry. And we're going to do things in small pieces, right? We want to identify the parts of the triangle. We want to understand how to use these ratios and and formulas. We need to understand how to use our calculator. Everybody's going to need their scientific calculator, and then we can tie it all together to actually solving problems. So each little piece is extremely important. So when we get to the end, promise you, all we're going to do is cross multiply and solve it. But to get to that point, we have to understand some things that are going on. So let's jump into it. So we're going to be working with these trigonometric ratios. Now, our focus is going to be on three of them: sine, cosine, and tangent. It is not sin, cos, and tan. Sine, cosine, and tangent. There are others. These are the ones we are going to focus on at the moment. And you should see them or be able to find them on your scientific calculator. Sometimes there are buttons right on the front. Sometimes you have to go into a trig or a math menu to find them. Every calculator is a little bit different. But we're going to work with sine, cosine, and tangent. Once we identify the parts of the triangle we're using, it's only one formula is going to work for us. So picking the formula depends on us picking or identifying the sides of the triangle correctly. So that's where we're going to start. So when we look at our right triangles, we always want to identify these four things, which is our reference angle. Now, it's not the right angle. For our purposes, it will be one of the acute angles. It could be either one, but we have to know which one we are basing all of our work on. We want to identify the hypotenuse, which is opposite the right angle. The opposite side, meaning the side opposite our reference angle. So again, we have to know our reference angle. And then the adjacent side, or the side next to the reference angle. And my suggestion is do them in this order because that's how you learned them. And that's the way you're probably most comfortable. You learned how to identify the hypotenuse. Then you learned about sides and angles that are opposite of each other. Now we're adding in the side next to the angle, meaning the adjacent. So let's go through that exercise quickly so we can identify the parts. So the yellow arrow is indicating our reference angle. So this is our angle, right? This is our angle. We want to identify the three sides. So opposite the right angle is the hypotenuse. Opposite our reference angle is the opposite side. And then this one is the adjacent. So again, the hypotenuse is quick and easy. We're used to that. Our reference angle and the side opposite. And then finally the side adjacent or next to our angle. Every angle has two sides, but one of them is already called the hypotenuse. Do that first. The other one is the adjacent. So again, our reference angle, and then we're going to identify the sides. We have the hypotenuse, the opposite, and the adjacent. And one more, because remember that picture could be rotated or reflected, and we don't want that to confuse us. Immediately know where your angle is. Then focus on your three sides. Most of us are comfortable with hypotenuse, so do that first. Angles and sides that are opposite of each other that are really important. So draw an arrow angle out of your angle, and it's going to point to the side opposite. And then we have the adjacent. In every one of our questions, we're going to be working with only two of those sides, but we have to know which two sides so that we can identify the correct formula, sine, cosine, or tangent. So you need to be comfortable with identifying the three sides. Next is we want to grab our calculator, and there's a few things. For our purposes at our level, we are going to do everything in degrees. So you need to make sure that your calculator is set to degrees. One way to test it is to do the sine of 30, and your answer should be 0.5. Now, again, every calculator works a little bit differently, how to set it to degrees or how to enter it. Some calculators, you hit the sine button first and then type 30. Some calculators, you type 30 and then hit the sine button. So you have to get comfortable with your calculator. But that's a quick test on any calculator. Again, at our level, for the purposes of this lesson, everything must be in degrees. Now, these are our three formulas. You can see each of the ratios or formulas has three variables: the angle, and then two sides of the triangle. We have to know this is our reference angle and which two sides of the triangle we're working with. Notice that if we identify which two sides we're working with at any time, only one of the formulas is going to work. If you're working with hypotenuse and opposite, there's only one formula that you could possibly use, and that's the sine. So we're going to be plugging in three things, and we're going to let our calculator do all the hard work. But the importance of identifying the three sides that we're working with. Just as a mnemonic, SOHCAHTOA is a very common mnemonic to help us remember the formulas. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's just look at how these work. Again, we identify the parts so that we can plug them into the formula. So let's see what's happening here. We're working with angle A as our reference angle. So that's the first thing we need to know, that this is our reference angle. That will allow us to identify the sides. So let's do that. We have the hypotenuse, the opposite, and the adjacent. Now that's very important because each of these formulas uses different sides. But now we can fill it in. So remember, sine, for example, uses opposite over hypotenuse. So I'm going to fill in my fraction. The sine of angle A is the opposite over the hypotenuse. Now, we're not solving anything yet. We're just learning how to set up the formula. Cosine is adjacent over hypotenuse. So cosine based on angle A. So the cosine of angle A equals 24 over 30. And finally, tangent is opposite over adjacent. So the tangent of angle A is 18 over 24. Now again, all we want to do here is just get comfortable filling in the formula. Sine, angle equals opposite over hypotenuse. So in this case, we're using angle A. It might have been 53 degrees in a different question or 27 degrees. We're just filling in a formula. We can't solve a formula that wasn't written. So we have to know the parts of the triangle so we can choose the formula, substitute everything we know, and then solve. But again, each formula uses different sides, so it's extremely important that we identify the sides first. Okay. So trigonometric ratios are extremely detailed. They're decimals. For example, sine is always going to be between 0 and 1. So we have to be really careful. We need to go at minimum to the 10,000ths. 10,000ths. That's 4 decimal places, right? Tens, tenths, hundredths, thousandths, 10,000ths. We need to be extremely accurate. So we're going to be very careful in our work here. When we enter a trig value, sine, cosine, tangent, when we use one of those ratios in our calculator, we need to grab that resulting decimal at a minimum to the 10,000ths place, which means we have to round it correctly. Otherwise, we might get some inconsistent results. So we're going to be very careful. Sometimes we're going to let the calculator do the hard work, but sometimes we have to intervene for consistency and make sure that we're following directions. So this is in your calculator. You're not going to have to use a table like this, but that's what we're asking our calculator to do. We're going to say sine of a 20-degree angle, and it's going to give us back a decimal. Or we might give the calculator, cosine 51 degrees, and it's going to return this little decimal. That's where we're going to let the calculator do all the hard work. So let's see what's going on. Purely a calculator exercise. And again, this is getting used to your calculator, but we want to enter the trigonometric ratio and get its value. So the sine of 30, and again, everything here is in degrees, even though it's not showing the degree symbol. Everything here is in degrees. So sine of 30. Again, we're getting used to our calculator, but our answer here is 0.5. Now, since we're going to go to the 10,000ths, we can tack those zeros on. In other cases, we're going to be careful how we get it from the calculator. So cosine 72. 0.3090. Now, do it on your calculator so that we are in agreement about the results, about the number of decimal places and the rounding if needed. 4663. Sine of 68. We get 0.927. And this one we had to round. Now, if you don't round it, or you let the calculator keep all the decimal places that it has, every calculator is different, that could cause a slight difference in our final results. So if we're told round to the 10,000ths, we have to follow those directions. Cosine 18 gives me 0.951. And again, I had to round here. 1. And finally, tangent of 74, 3.4874. Okay, notice we did not say 4 digits, we said 4 decimal places, 10,000ths place. Tangent, out of sine, cosine, and tangent is the only one that could have a whole number representative, meaning a ones digit. a 1, a 2, a 3. Sine and cosine will always be values between 0 and 1. Okay. So we've identified the parts of the triangle. We've gotten familiar with the formula. And we now know how to use our calculator for the purposes of trigonometry. So it's time that we wrap that all up and tie it together so that we're actually able to solve a problem. So let's look at this example. This one is completely worked out for us, but let's walk through it. The directions there are basically telling us when we type in the sine or cosine or tangent, when we type in the trigonometry, we want to get the decimal to the 10,000ths. The final answer should be rounded to the tenths. So keep this in mind. All trig, we're going to go to the 10,000ths. Final answer, we're rounding to the 10th. This will be given in the directions. When they tell you round to the 10th or round to the 100th, they're giving you that final direction. This you need to know. And that could cause a slight difference in final answers. So we need to be careful there. Now, what I'm going to do is I'm just going to write the formulas here. So we can see them and we can understand what's happening in this question. You should have your formula sheet available to you. Okay, so let's look at this example and then we'll do some ourselves. First, they're giving us our reference angle. That's our angle. We're going to identify the sides. We have our hypotenuse, and across we have the opposite. Now I'm going to stop there. I'm not labeling the adjacent. I can, but I'm not going to. What I want you guys to see here is we're not asked for the adjacent. So right now, I don't care about the adjacent. This is what I'm saying. If we can identify the parts that we're going to use, then we can pick the formula. We are using the angle, obviously. We're given the hypotenuse, so if we're given it, we're going to use it. And we're looking for the opposite. There's only one formula that uses the opposite and the hypotenuse together. Sine. So we have no choice. Once we identify the parts, we have no choice in our formula selection. There's only one to use. And we're just going to plug it in. So look at our substitution here. We're using the sine ratio. We filled in our angle of 40 degrees, our opposite over our hypotenuse. Now we're going to grab that calculator. And all we're doing is converting the sine 40 into a decimal. I got 0.6428. And now we're cross multiplying. Put that decimal over a 1 and cross multiply. And since our direction said round to the 10th, I got 18.0. So again, identify the side you know, the side you're looking for. That forces you into one formula. Substitute. We're going to convert. Sorry about that. We're going to convert trig to a decimal using our calculator. and then we're going to cross multiply. And let's keep it that simple at the moment. All right, let's do a couple. So again, we're going to use the same directions. We're going to do our trig to the 10,000th, and we're going to do our final answer to the 10th. There's our angle. So we're going to identify the sides. Hypotenuse, adjacent. So check your formula sheet, and there's only one formula that's going to work for us. Cosine of the angle equals adjacent over hypotenuse. So we're going to substitute cosine 73 degrees. The adjacent is x, and the hypotenuse is 6. I'm just going to shrink this a little bit. Grab our calculator. The cosine of 73 degrees, I got 0.292, and I have to round correctly. And that equals x over 6. If you just grab the first 4 decimals, our answers might vary a little bit. If you use all the decimals in the calculator, again, our answers might vary a little bit. That's a rounding error. Either way we're rounding, it's just how we're rounding. If we round differently, we could get different results. Every time you round, you're making your answer a little bit wrong or a little bit less accurate. So if we round differently, we're going to get different results. We're going to put this over 1, and we're going to cross multiply. Well, 1 times x is x. So now we have 0.2924 times 6, and I get 1.7544, but the directions were to the 10th. So 1.8 is going to be my final answer. Let's take a look at B. Okay. We have our angle, the opposite, and the adjacent. There is only one trig formula that uses opposite and adjacent at the same time. So you need your formula sheets. Let's plug in everything we can. Tangent, 37 degrees. The opposite over the adjacent. Identify the sides. Grab the correct formula. Substitute the 3 things. Now we pick up our calculator. We're going to convert tangent 37 to a decimal. So 0.7536. Again, make sure that we're rounding. We're going to put it over 1, and we're going to cross multiply. Again, 1 times x is x. 0.7536 times 12 is 9.0432. Directions were to the 10th, so we get 9.0. Make sure you're writing out your work, especially your cross multiplication. Okay. Let's do 2 more together. Same directions, we're rounding to our final answer to the tenths. Identify the parts, angle, hypotenuse, opposite. Choose your formula. Opposite and hypotenuse, that has to be sine. Fill it in. Sine 51 degrees. Opposite is 14, hypotenuse is x. Do not touch your calculator until you fill in the formula. Now, I'm going to do sine of 51 degrees, and I got 0.7771, and that equals 14 over x. Put it over 1 and cross multiply. This is where people make mistakes. Pay attention to what you're doing here. 1 times 14 is 14. On the other side, we have 0.7771 times x. I'm just going to shrink this a little bit. Now we have to divide by the number next to x. That's just basic algebra, but we have to be careful. So it's 14 divided by 0.7771 for an answer of 18.0. Now think about this. We were looking for the hypotenuse, so it has to be bigger than 14. We can catch mistakes very easily if we're attentive to some of the details. So write out that cross multiplication. Right? I don't want to go through shortcuts because I want you guys to understand what these values mean. 0.777, that's a little bit over 75%. So it's telling us the opposite is a little bit more than 75% or 3/4 of the hypotenuse. So we want to get a feeling for what these numbers mean, not just gloss over them to get a correct answer. The goal is to understand, not just do. So in our last example here, again, identify your angle, identify your two sides, hypotenuse and adjacent. We're going to grab our formula, hypotenuse and adjacent. There is only one trig formula that we can use, cosine. We're going to plug it in, fill in what we know, cosine 59 degrees. The adjacent is 34, and the hypotenuse is x. Now I'll grab my calculator for cosine 59 degrees, 0.5150. Put it over 1 and cross multiply. 1 times 34 is 34. Equals 0.5150x. We always divide by the number next to x, by the coefficient. And 34 divided by 0.5150 is 66.0. Again, in this example, we were looking for the hypotenuse, so it has to be more than 34. You'll know if you set it up upside down or if you set it up divided backwards by the answer in many cases. So look to make sure that your answer makes sense, but write out your work. Most mistakes are going to be by not writing out your work. Identify and label the sides, choose the formula, plug in for the angle and the two sides, convert the trig ratio to a decimal, and cross multiply. And of course, solve for x. All right, so we have some basic right triangle trigonometry, and we're going to do some practice with that. We should be able to apply this, whether there's one triangle or multiple triangles connected or a word problem. If we draw it, we have a triangle, we have an angle on one side, we're using trigonometry to find the other sides. Okay. All right, let's do some practice with it.